So everybody, this is a guided walkthrough for the war machine that is hosted over at the VulNyx website at vulnyx.com. So the first thing we need to do when we do any of these CTF boxes is we need to identify where the machine is on the network. So what we're going to do is we're going to use the nmap tool to find out where the machine is on the network. So we're just going to run nmap with the -sn argument to run a ping sweep on this network range. So it's going to try to figure out which machines are online. It's going to call out to every one of the machines on the in the network range, and if it gets a response, it'll report that machine as being online. So there are only 2 machines that are running the VirtualBox network interface card, which means that they're virtual machines that are on our network. So this one at address number 5, this is our machine. So our attacker machine is at address number 5, and the vulnerable machine is this one right over here, which is located at address number 25. So we're going to go ahead and do another scan, another nmap scan rather, against machine number 25. And we're going to run nmap with these arguments here. We're going to do -p- to scan all network ports. We're going to do -s C V for versioning information and common scripts against whatever services that we discover. We're going to run it with -vv for very verbose output, which means that we're going to receive output before the scan finishes, which is actually very important when we're trying to save time. And we're going to run it with 5 threads, which means that it's going to run very, very fast. And hopefully we don't get any false positives because it's running so fast. Anyway, let's execute that scan. And we're going to see a bunch of open ports on the system. So we've discovered open port 135, 139, and 445. These are all TCP ports because this is a TCP scan that we're running right now. There's also port 88 open on the system, which is usually running some sort of HTTP proxy service. So what we can do while we're waiting for all the other scans to come back is we can investigate this web service right here. So we can go ahead and access it from our browser. So we're going to do HTTP, and it's going to be 198, 168, 225 on port 8080. And we're going to see this. So this is Apache Tomcat. This is Apache Tomcat. It's basically it's a free server that runs Java applications, or they're called applets, I think, or servlets. Not exactly sure what the terminology is, but let's learn a little bit more about this with our little presentation. So here. Okay, so this is Apache Tomcat, which with default credentials. So this is the way that we're going to be we're getting into the system. So Apache Tomcat is a Java-enabled web server software which allows Java servlets to be run on web pages. If a malicious user is able to gain admin-level access to a Tomcat server, malicious Java code, which are called war files, they could be deployed on the website. So in this case, the default credentials for the Tomcat Manager page are in place, so we can just log in. So let's talk a little bit more about how we would determine the default credentials for this particular application. So it's we're going to be doing a couple of tricks, but let's go back to the application here. So inside of Apache Tomcat, you can click on this section right here. It's called Manager App. Over here, we figured out that the username is admin and the password is Tomcat, Tomcat, and then sign in. And now we're in the application. So it says here, this is the Tomcat application manager. So from here, what we can do is we can upload Java files, which are called war files, and we can serve those applications on the server here. But anyways, so what we want to do is we want to create a malicious.war file to upload to the application, and then when we access it, it's going to run our malicious code. So this is what we're going to do. We're going to go over to Kali Linux, and then we're going to run this command. So nsf venom, and we're going to create a malicious war file with this handy dandy tool. It's called msf venom. We can specify a payload. In this case, it is because the application is running Java code, we have to supply a Java payload, which is a reverse shell. So we're going to do a reverse shell connection when the code is executed. We're going to have it communicate with our attacker machine, which is at this IP address right here, and it's going to be listening on this port that we specify over here. The format for the file is going to be a war file, because that's what Apache Tomcat uses, and we're going to call the file revshell.war. So revshell stands for reverse shell. Let's go ahead and create that file right now. We've created our revshell.war file that we can upload to the server over here, and we see that it is over here. All we need to do now is set up our reverse shell listener. So we're just going to go over to our reverse shell tab, and we're going to run rl wrap with netcat, and we're going to listen on port 443. So netcat is our listener program, and we're going to use it with this other supplementary program called rl wrap. It basically gives our netcat shell a little bit more functionality. We can move inside the terminal, inside of the terminal line like this if we have rl wrap, and we can also do command history when we're using rl wrap. It's a very handy dandy little thing, especially when we're dealing with Windows reverse shells. So we're going to run the listener, and now our reverse shell is ready for connections. So the next thing we're going to do is we're going to go back to the web application, and we're going to upload the malicious war file. So we can do that by going down to here, war file to deploy. We're going to click on browse. We're going to select our working directory, which is the temp directory, and we're going to select the revshell.war file. After that, click open, and then click on deploy. So it says here revshell.war, click on deploy, and we see that a new endpoint has been created on the application, which is revshell, which is the name of the file. So we can actually access it by clicking on this link right here. And when we click on it, we see that the browser tab doesn't come back right away. Let's go ahead and look at our reverse shell listener to see what happened. So we see here that we now have a reverse shell on the system. When we ask who am I, it says we are anti-authority local service, which means we are. All right, so the first thing we need to do after we get into a system is we need to figure out what privileges our user has. We can figure out what privileges we have on a Windows system by doing whoami/priv. And we see here that we've got a number of interesting privileges. Only a couple of them are enabled, unfortunately. So which ones are enabled? We've got SE change notify privilege. We've got SE impersonate privilege, which is a favorite of ours. And we have SE create global privilege. So this is actually the privilege we're going to be taking advantage of today. It's called SE impersonate privilege. Okay, so I've got a little presentation about this. Here we go. So this is privilege escalation via the SE impersonate privilege. So our user has the Windows SE impersonate privilege, which means that they're able to assume the identity of different users in certain cases. So sometimes the SE impersonate privilege can be abused by using a family of Windows exploits called potato exploits. But unfortunately, modern versions of Windows, such as Windows 10 and Windows 11, are less likely to be vulnerable to these potato exploits. So a more modern exploit that takes advantage of the SeImpersonate privilege is the Printspoofer exploit, which affects Windows 10, Server 2016, and Server 2019 operating systems. And in order to conduct a Printspoofer attack, we'll figure out that that this thing is running. So sc query spooler, and so the print spooler is running on the target. All right. So, anyways, let's take advantage of this SeImpersonate with the Printspoofer. So, if we go over to GitHub and we were to look up this this exploit over here, Printspoofer, GitHub, we're going to find this GitHub project over here. Let's see. Let me see if I've got the same link. Yeah, it's the same link over here. So if anybody's interested in this GitHub project with the exploit, here you go. So what we need to do is we need to download the binary for this for the exploit. We can go over to the releases over here, and then we can download the executable. So Printspoofer, we are dealing with the 64-bit processor. No version of Windows 10 is going to be running a 32-bit processor. So we just need to copy this. And actually, one thing that we need to determine is that this indeed is a version of Windows 10, and we can figure that out by running the systeminfo command. So we can figure out that this is running Windows 10 Pro with this particular build version, and this is indeed a 64-bit processor right here, x64 based PC. Okay. So next, what we need to do is we need to download the exploit binary. So we're just going to go over here, and we're just gonna use wget to download the file. And the next thing we need to do is we need to upload the file to the target. So in this case, we can use an SMB server. We can host our own SMB server on Kali Linux, and then we can download the file from the Windows box using SMB. So the way we would do that is we would run this this tool right here. It's called Impacket SMB server. We need to supply a name of the file share we're going to host. We're just going to call it A, and then we need to provide where the files are going to be located, which is the current directory, which is dot. And then we need to supply. We're just going to give this argument here just for fun, SMV2 support, just in case we were dealing with a version of SMB that is dealing with SMB version 2. So after we do that, our SMB server is going to be stood up, and then we can download the file from our attacker machine on the Windows box. So back at the reverse shell, we're going to move into the public directory, because the public directory is usually universally writable, and we can put any nice little files up on there. So from here, we're going to copy from our attacker machine. In the A file share, we're going to download the Printspoofer 64.exe file. Okay, so after we do that, we're going to see that we've copied the file successfully. And to run the file, all we need to run this exploit file, all we need to do is run the name of the file, and we need to specify these arguments right here, which is going to open up a command prompt for us. And because we're taking advantage of the SeImpersonate privilege, we're going to get a command prompt in the context of the highest level user, the NT authority system user. So we go ahead and run the exploit. When we ask who am I, it says we are the highest level user, the NT authority system user. So we can do this redeem right here.
What are you? I'm system root.
Okay, awesome. All right, so from here, what we need to do is we need to go into the administrator's desktop directory and read their flag file. So the flag file is basically proof that you've gained access to gain the highest level of access and are able to read any file that you want inside the file system. So we just need to go into C users administrator desktop. And in this directory, there is the root.txt file. We're not going to read the root.txt file in the traditional way because the organizers over at VulNyx probably don't want us to leak the contents of flags on these walkthroughs. So we're just going to read the file, but redirect it into another file called iReadRoot.txt. So because we were able to create this file, iReadRoot.txt, and it has the same size as the root.txt flag, we've essentially completed the exercise. All right, so this was a guided walkthrough for the War Machine over at VulNyx.com. And everybody, if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the YouTube video and leave a comment underneath the video. But until next time, HackerFrogs out!
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.